This myth is pervasive in the ham radio community and among CBers. The myth is that reflected power goes inside the transmitter and destroys your finals. Now, there are previous videos on this channel explaining why that does not happen if you're using an antenna tuner. Reflected power is re-reflected back to the antenna by the tuner and radiated. Now, that should be obvious. What's the SWR between a properly adjusted tuner and your transmitter? 1. Which means 0. Actually, there is none. There's no reflected power. Which means no reflected power is getting past the tuner and into your transmitter, and the power meter on your transmitter shows full power, let's say 100 watts, going into the tuner. But what if there is no tuner? Then does reflected power fry your finals? Here's what happens. According to a well-known antenna engineer, ham radio operator, and prolific writer who used the pen name of Kurt Sturba. Let's say you have a transmitter putting out 100 watts into a high SWR of about 5.8 to 1. When that first 100-watt wave reaches the load, what's going to happen? Well, that SWR, half the power, 50 watts, is going to be reflected back. Now what happens? Instead of that 50 watts going into the transmitter, and at the same time transmitter power coming out, the two waves, transmitter power and reflected power, combine depending on the impedances involved. So, according to Kurt, the net result is that the transmitter power output is reduced to 50 watts in this case, but then that combines with the 50 watts reflected. You still have a power output of 100 watts. There is no loss even with no antenna tuner. But does that mean that 100 watts is radiated? Now think about it. Every time a 100-watt wave arrives at the antenna, half of it gets reflected back, which means only 50 watts is actually accepted by the antenna. Now, Kurt says this is just an example. He says the transmitter may drop to some other power level because the outputs of transistor amplifiers are sensitive to load impedance. Here's how this is explained by the ARRL antenna book. The power reflected from a mismatch load does not represent an actual loss, except as it is attenuated in traveling back to the input end of the line. The actual effect is to reduce the power taken from the source. That is, the returned power reduces the coupling between the power source and the line. This is easily overcome by readjusting the coupling until the actual power put into the line is the same as it would be with a matched load. What it's saying is that with the addition of a properly adjusted antenna tuner, in the case of a 100-watt transmitter, its full power will be put into the line just as if it was a matched load. Now, none of this is very practical. I mean, who's going to be operating a transmitter directly into an SWR of 5.8 to 1? Your transmitter won't even attempt that because of its protection circuits. But I like to know what happens in transmission lines, and so do you. I mean, that's why you're here. We're ham radio operators, aren't we? A little more now about Kurt Sturba. He was W6QEU and founder of Jam Pro Antennas in 1959, which still supplies antennas for commercial FM and TV broadcasting. He designed and patented the circular polarized FM antenna and has several patents. Kurt was also a writer for World Radio magazine and wrote a monthly column often poking fun at the exaggerated claims of makers of ham radio antennas. You can download many of his columns for free from the website of Palomar Engineers. Now, I highly recommend that for any radio operator who wants to understand what's really going on in transmission lines and antennas and stop believing myths. Consider subscribing to this channel in 73.